Welcome back to Walking on the Cloud, and today we're going to take another ride. So what we're going to talk about today is networking in the cloud, right? So networking in the cloud comes in many formats. I'm going to start with the most frequently mentioned one, which is the VPC or virtual private cloud, right? VPCs exist in multiple cloud providers, and a VPC is essentially an isolated environment where you can create your own networks. Those networks are layer 2 isolated. So basically, when you create a subnet or a subnetwork in a VPC, you are segmenting that VPC into very secure environments where even layer 2 network traffic is completely contained within that network. Now, there are some differences in designs of virtual networks or virtual private clouds and subnetworks in different cloud environments. And today I'm going to talk about my opinion on what the right approach is. Now, of course, many will disagree, but this is just my opinion, and I'll tell you how I came to this opinion over time. So I used to believe in networking, simplicity was the key, right? That was my belief. As a systems admin, I would have to interact with the network, and of course later when I went into virtualization, the network just becomes a part of configuring your environment. So I got to learn a lot about private networking, a lot about routing, a lot about the way things are done in different environments. I also worked for a provider that had some WAN environment set up. They had their own autonomous system number. They were part of the global BGP network, and they were able to provide you with public IP addresses, right? That's something that essentially gave me a lot of exposure to networking. I've never been a networking admin myself. I've never been a networking engineer as far as having a role like that in any company, but I have worked with different manufacturers. I've worked with Cisco switches, Arista. I've worked with what else? HP switches, 3Com back in the day, right? That's like a ton of different switches. I worked with routing equipment, either on those switches or routers from those same sort of manufacturers. I work with a lot of firewall solutions. So I used to be Palo Alto Network certified. I worked with IPSense a lot. Sorry, PFSense. What am I talking about here? PFSense. I worked with different devices from different manufacturers. Barracuda was one of them. My favorite firewall, jokingly. Anyway, from the networking exposure that I have, I've formed an opinion on the way VPCs are designed and the way they should be designed. Now, one common question is, when you have a VPC, do you have to segment that VPC into either a subnet that is in one availability zone, or do you want to have a subnet spreading the availability zone, or do you want to just push that subnet across the globe onto multiple regions and make sure that you can access services on that same layer 2 scope? Now, all of these three are possible, and I'm going to discuss why I think some design approaches are better than other design approaches. Now, firstly, when you are with cloud providers, you will have regions. Regions are geographical areas where you essentially know the general proximity where your data centers are, right? So for example, a region in AWS would be called US East 1 or North Virginia, right? A region in GCP would be again tagged with a tag that would put it into that region. Microsoft has its own approach where a region is actually an availability zone. Now, with these Not all regions are availability zone. Don't quote me on that. There are some regions that have multiple availability zones with Azure, so don't quote me on that. But generally, you got a region, then you have availability zones. With availability zones, you essentially define, okay, I am in this general proximity of this town or this state or this general big city or whatever, and an availability zone lets you be highly available, right? So an availability zone isolates your resources into fault tolerance environments, right? So any kind of failure in one availability zone could technically bring down the whole availability zone. Not any kind of failure, some general major failures. So for example, with cloud providers, what they usually do is they put availability zones into different sort of data centers that are connected to different power providers, different ISPs. They will even lie on different fault zones for earthquakes, different levels of a specific floodplain, etc. Right? So you can be sure that even if there's a major disaster, at least some of the availability zones will survive in that environment. Well, major disaster, you know, except for like huge solar storm that takes out all the electricity, or a meteor striking the earth or something like that. But even a meteor striking the earth is not going to take out all availability zones. However, I don't know how much use we'll have for computing if there's a general sort of extinction level event. That's just my sort of personal opinion, that I don't really know if that's going to be in use. Farming or other, farming pretty much is going to save us if we have an extinction level event. There's not enough wildlife to even feed ourselves anymore. So as we see, disaster can happen, right? This is clearly visible from the situation that we're in right now, and these disasters, we're not prepared for them. As humanity is not prepared for disaster. What we're prepared for is running our systems on a day-to-day basis at 100% max, right? If society were designed like we design our computer systems, I would be super happy to live in society like that, where, you know, you can lose half of the functionality of the society and not everything breaks down. As it is right now, everything is breaking down. All right, that segue was unnecessary, but still, let me get down to the designs of VPCs. Now, when you are designing your network, what you want to do is you want to isolate segments of your network as much as possible. Now, I didn't used to believe this, right? I used to find that the approach where you can send a layer 2 packet across the globe, across any line, is the best approach possible, right? Network virtualization at a level where you put pack layer 2 packets into layer 3 connectivity, and you can talk straight on the network to anybody, right? This is something that, for example, if I look at open source solutions, Open vSwitch is something like that, right? Open vSwitch can create GRE tunnels between all instances that run Open vSwitch, and then it creates an overlay network. So it lays a layer 2 network over the layer 3 network that these switches are connected to. That is really cool if you have a specific use case that requires layer 2 communication, right? In general purposes, this is kind of a bad idea. Why is this kind of a bad idea? Well, because you have to be prepared for failure. So now you're combining all your networks into one network where segments of that network can fail, be taken out, and then your machines on the network are going to be wondering what's going on, right? And I know everybody's not going to agree with me. I know there's mitigation ways for this, but yes, you've set up a complicated environment that's complicated to mitigate when you have a certain failure inside of it, but instead of having the simplest solutions, you've gone for a very, very, very difficult and hard to manage solution. Sure, it gives you layer 2 capability across the globe. If you have a use case for that, perfect. Otherwise, I think the approach that AWS has is good. Okay, listen now. Don't start screaming and kicking. Listen to me. So the way their approach is you create a VPC, which is just a logical definition for the scope of IP addresses that you're able to use with subnets, right? And then you create subnets, and each subnet is tied to a specific availability zone. So if you are going to be losing an availability zone, you are losing that subnet, right? And then you've got pairs or triplets, right? 2 or 3 availability zones in use, and you got 3 availability zones for your application. You deploy that application across those 3 availability zones. Now, they're connected together by layer 3 routing within the VPC, right? So this is completely transparent to you. All you need to know is you set up one IP address range in one subnet, another IP address range in another subnet, and then the third IP address range in a third subnet. They all must belong to the range defined in the VPC, but they are different. They are different networks, and you're dropping your application into 3 different networks. Now that might sound complicated, but it's actually a good idea when you think about failures, when you think about security issues, right? First thing you can do, now you can control access to your application on 3 different isolated environments. If an availability zone goes down, you know you're losing that whole subnet. You don't know, it doesn't, so if you have a traditional environment and you've got a network spanned across 3 availability zones, if a third of your network goes down, unless you have a very sort of complex way of tracking your resources, you're not going to know what's not available, what failed, why is this machine not responding, all the other machines are responding. Think of the days when you had a subnet and you were pinging across the subnet, across maybe a few switches, right? And one of the switches was acting up. How do you isolate that fault to that switch, and how do you stop people from messing up the situation more? That's a sort of thing that's logical, that's in your head, right? So I think with the VPC design, simplicity matters. And I'm not on AWS's side. I do OpenStack. I'm a certified OpenStack instructor. Well, if that exists. I'm an OpenStack training provider myself, right? An independent training provider. I'm a certified AWS instructor, and I'm a certified Google trainer, right? So these are the 3 clouds that I know pretty well if I can teach people about them. And I'm not saying it's better. I'm saying my opinion is that the simplest design for the VPC actually works best. Now, if you want, you can replicate this in OpenStack, you can replicate this in GCP, but it's not the default way of operation, right? Especially, well, with OpenStack, there's no default way of operation. Let's say with OpenStack, you go for the Open vSwitch, you go for the GRE tunnels, and you start building your overlay networks across the environment. Great, right? But you gotta have your cells figured out, you gotta have your monitoring figured out, so it can correlate. If an availability zone goes down, you know exactly which systems are gonna be affected, right? And I'm talking about tens of thousands, hundreds of thousands, millions of instances. I'm not talking about your enterprise environment where you've got, 3 racks of servers and each of them is an availability zone. I'm talking about when you're in multiple data centers across the globe, when you got a global application. It's hard just because of the sheer volume to track what has failed, what should be working, what should be down. Now, if you have gone to the point where you're completely automating this, good for you. But 90% of the businesses that I get to work with or am in touch with through training have not been able to get to the point where everything is super automated, right? They still have a lot of human power invested in this. Now, when you are automating everything, when you're automating your recovery, again, that doesn't become so much of an issue. But for now, simplicity is gonna give you a big advantage when you need to troubleshoot, when you need to understand what's going on, when you have to have situational awareness about your application. Infrastructure simplicity is more important than anything, right? Even AWS itself says, this is how we design it, right? It's for fault isolation and for essentially having an understanding of what's happening inside of your environment. But now that you have this environment, don't try to over design it, right? Don't make too many VPC subnets, because that's going to increase your complexity, right? And that's going to affect your situational awareness. And it's basically the human factor that is limiting us. The technology itself is great, right? The technology itself, having the ability to span a network across the globe, especially in a cloud connected environment where you need to quickly move resources to another data center, where you need to fail over, when you need to make sure that you're online as much as possible. It's great to have that. It's great to have the overlay networks. It's great to have subnets that can span availability zones. But the drawback is it's more complicated and it will reduce your situational awareness. And that's one thing that I need to talk about a little bit more in another video. Now, I've been rambling long enough about this. It's up to you how you design your networks, right? Just understand that the benefits, and there's benefits and there's drawbacks, right? That's all I'm trying to say here. In the end, it's your environment. It's what you feel is the best for your application. It's where your use case is covered and where you have the ability to figure out what's going on. All right, I'm gonna leave you with that. I'm gonna end it on this note, and I'm gonna say thank you very much for watching this fairly long video. It's more of a rambling about VPCs than anything else. And of course, comment, subscribe, make sure you got that notification turned on so that you hear when my new videos, that you get a word about my new videos, if you're interested in this kind of stuff. If you're not interested, then thank you for watching, and I probably won't see you again. For all of you who are interested, thank you for watching. I will see you in the next episode of Walking on the Cloud, or as now it looks like it's going to be more like Driving on the Cloud with Marco.